In just a couple of days' time from the making of this video, NASA will be crashing its only Saturn orbiter into the planet. As Cassini enters Saturn's atmosphere, it will aim its antenna towards Earth, transmitting data about the composition of the atmosphere in real time until the thrusters can no longer keep the probe steady due to the atmospheric drag. Cassini will then burn up in Saturn's atmosphere, ending a 20-year-long mission from launch to final descent. This spacecraft has been an absolute trooper, surviving and performing in the harsh environment of space, and personally I will be sad to see it go. The legacy of Cassini will be felt for years to come though, as scientists are able to trawl over the huge amount of data Cassini has collected during its mission. During the final part of Cassini's voyage, called the grand finale, it has been able to approach the planet closer than ever before, darting in between the rings. But what has it seen? Has this unique perspective shown anything we've never seen before? Well, starting with the moons of Saturn, it has seen some of the shepherd moons in unprecedented detail. This is a close approach of Atlas, a 40-kilometer wide moon near the outskirts of the A-ring. What looks remarkable about this moon is the lack of impact craters on its apparently smooth surface, making it look absolutely bizarre. Dust from the rings is collecting over the surface, particularly around the equator of the moon, smoothing it over and giving it this disc shape. A similar thing happens with the second innermost moon of Saturn, Pan, at 30 kilometers wide and found in the NK gap. Any particles from the rings that stray into the 350 kilometer wide path get swept up by Pan. This keeps the NK gap steady and constant. Daphnis is another shepherd moon, but sadly not seen in quite so much detail. But due to the gap it's located in, its effect can be seen for hundreds of kilometers. It's only 8 kilometers in diameter and found in a very narrow gap in the A-ring called the Keeler Gap. Its gravity is very weak, but it's just enough to whisk the nearby dust particles as it brushes by. This creates these waves or ripple effect in the nearby rings, sometimes even ripping material directly out of the ring, visible in this little trail here. Not only do these rings move from side to side, but up and down too, as can be seen by the shadows they create. I can only imagine what it must be like to sit on Daphnis and watch as waves follow its orbital path, with glorious Saturn and its many other moons in the background. It would be quite the sight to behold. Talking of the rings though, Cassini has been able to capture some spectacular images. One of my favourites from the grand finale is this one, showcasing the Janus 2:1 spiral density wave. Amazingly, what you're looking at here is the result of the same process that creates spiral galaxies, just a lot more tightly wound. What appears to be many separate rings is actually only 2 spiral arms looping around the planet many times. So every second line you see in the image belongs to the same spiral arm. This image is part of the B ring, at a position where the ring orbits twice for every 1 orbit of Saturn's moon Janus, causing an orbital resonance. This photo gives the illusion that the image is tilted away at the top left, but this isn't the case. The illusion is caused by the way density waves propagate from the planet, the wavelength decreasing with the distance from the resonance. And this is where this resonance gets even more mind-blowing. Janus, the moon that contributes to the resonance, switches orbital positions every 4 years with its close neighbour moon, Epimetheus. Every time this switch takes place, the rings respond, creating a new crest in the waves. NASA says the distance between any pair of crests corresponds to 4 years worth of waves propagating downstream from the resonance, which means the wave seen here encodes many decades worth of the orbital history of Janus and Epimetheus. According to this interpretation, the part of the wave at the very upper left of this image corresponds to the positions of Janus and Epimetheus around the time of the Voyager flybys in 1980 and 1981. This encoding reminds me a bit of a tree trunk encoding how many years it's been alive by the amount of rings it has. Simply amazing. Apart from some other beautiful and detailed images of the rings, Other interesting sightings have been these little propeller features dotted around the rings in a number of locations. This image shows both sides of the ring. The top image shows the illuminated side and the bottom the unlit side. Even though the scale of the image is only about 500 meters per pixel, the moonlit might not even be able to be resolved. You might just be able to see some trace of it in this top image, but what can be seen is that the moonlet is physically connected to the rings by this band of materials. As I mentioned, this wasn't the only moonlet trying to create a gap in the rings. Here is another found right next to the Encke gap. And here is another, and probably the biggest out of all three. None of these moonlets are thought to be bigger than 2 kilometers, and probably have the density of a snowball. The last interesting thing Cassini has been able to image within the rings is extremely small but solid objects which have been formed around the F ring, potentially caused by the perturbations of some of the shepherd moons around there. They seem to be solid as they have crashed into the F ring a number of times, kicking out dust and particles, which sometimes even follow their orbit, as can be seen by the haze around them. The objects themselves are not actually visible due to the dust obscuring the view. Lastly, let's have a look at the planet itself. As Saturn's northern hemisphere is in full summer at the moment, its remarkable hexagon around the pole is in full view. In the center of the hexagon is found a permanent polar vortex with the eye wall of a massive hurricane. Interestingly, the pole seems to be changing color with the season, as you can see quite clearly in comparison to 2012, where the pole appeared quite dark in color. With the assistance of other wavelengths of light, other storms are visible and can be seen dotted all over the planet, as well as bands reminiscent of Jupiter, but just not quite so vivid in natural light. Also, because of the proximity of Cassini to the planet, it is able to get a good look at the planet's horizon. On the left of the image can be seen a haze in the stratosphere of the atmosphere that disappears towards the right of the image. When Cassini does enter the atmosphere on its final approach, it is thought that it will not survive to reach the depth of this haze. Because of the composition of Saturn, it is not expected that Cassini will be able to see much more detail of the atmosphere than what you would find in this image, but what is of particular interest to scientists is what the atmosphere consists of, and sadly that will be the last thing Cassini will ever send back to Earth before burning up in the atmosphere. And there we have it, a final look at Cassini's grand finale. I'd just like to extend my thanks to the Cassini team that made all of this space exploration and discovery possible. We have seen and learned things that would have never been possible if it wasn't for these intelligent and dedicated individuals, and I can only hope the discoveries will continue as Cassini's data is further analysed, and also further missions get underway. If you would like to learn more about Cassini, Saturn and its moons, then check out the playlist I have for them here. Otherwise, if you're new to the channel, a big welcome to you, and I hope you'll stick around by subscribing so you don't miss out on any future content. To my subscribers, I would ask that you consider clicking on this bell symbol next to the subscription so you'll get notified of any uploads in the future. And lastly, a big thank you to my continued support on my Patreon page. The list of patrons keeps getting longer and I'm so grateful to you all for helping me make videos. Big shout out in this video to Abba, who donated $50. All the best everyone, and I will see you next time.